Every day, more than 45,000 flights are handled by the FAA. But aging infrastructure, growing demand, emerging technologies, and increasingly disruptive weather are putting new pressure on the engineering systems that keep aviation going. Engineers are responding with smarter air traffic systems, revolutionary aircraft designs, and entirely new transportation networks in the sky. But can engineering keep commercial aviation safe, efficient, and adaptable for the future? Hello, Circuiteers! From the moment an aircraft leaves the gate until it reaches its destination, aviation depends on thousands of engineering decisions. Today, we're exploring how engineers are preparing aviation for the decades ahead. Commercial aviation relies on a huge engineering network that connects aircraft, airports, controllers, weather systems, communications equipment, and navigation technologies. Many components of that network were designed decades ago, yet today they must support growing passenger demand, more complex operations, and increasing weather disruptions. This year, the FAA awarded Airspace Intelligence with an $875 million contract to modernize the national airspace system with software and AI capabilities. The 12-year award will allow ASI engineers to support the FAA's effort to build a new air traffic control system that integrates operational data, predictive analytics, and traffic management capabilities. ASI's Flyways AI platform is already supporting flight routing, air traffic management, and safety operations across a significant portion of U.S. domestic air travel. Of course, smarter skies require smarter aircraft. Our next story looks at a NASA aircraft designed to solve one of aviation's most famous engineering problems. For decades, supersonic commercial travel has been limited by the sonic boom, a powerful shockwave generated when an aircraft exceeds the speed of sound. NASA's X-59 experimental aircraft, part of its Quest mission, was engineered specifically to change that. The X-59's unusually long nose and carefully shaped airframe are engineered to spread out pressure waves before they reach the ground. The goal is to transform a loud sonic boom into a much quieter sonic thump. To achieve that, engineers relied on advanced computational modeling, aerodynamic analysis, and extensive testing to refine the aircraft's shape and performance. The X-59 hit a major milestone in June of this year, completing its first supersonic flight at its target mission conditions of Mach 1.4 at an altitude of 55,000 feet. Designed and engineered by Lockheed Martin, the X-59 is on its way to being unstoppable. Listen, Circuiteers, the future of aviation may involve more than just traditional airplanes. Our last story explores how engineers are creating entirely new transportation networks in the sky. Advanced Air Mobility, or AAM, is a growing field focused on developing new forms of transportation using electric vertical takeoff and landing aircrafts, often called eVTOLs. Designing these vehicles is only part of the challenge. Engineers must also create the systems that allow them to operate safely at scale. That includes communications networks, charging systems, vertiports, traffic management platforms, and the digital infrastructure capable of coordinating large numbers of aircrafts while operating in shared airspace. Researchers are also exploring how automation and AI could help identify potential hazards, support decision-making, and improve safety across future transportation networks. The result could be an aviation system that extends beyond airports, connecting communities through new regional transportation options while integrating seamlessly with existing air travel. So, Circuiteers, can engineering keep commercial aviation safe, efficient, and adaptable for the future? From modernizing airspace and advancing aircraft technologies to integrating automation, communications networks, and entirely new transportation systems, engineers are working to build smarter skies and more resilient aviation systems than ever before. And if you enjoyed this week's episode of the Circuit News, don't forget to like, subscribe, and click those bell notifications for more incredible engineering. See you next week. And a special thank you to the Ming Hsieh Institute at USC Viterbi for making this episode possible.